Thank you very much for joining the session. I feel that I'm with friends and family here, so that's pretty good. I will be talking a little bit about building developer experiences for the cloud, and especially on top of Kubernetes, because that's kind of like the field where I'm working on. This presentation is pretty short, so I'm just going to discuss some topics very at a high level, but I'm open for questions, and we can catch up outside if you have questions about the demo that I will be showing. So I will be talking a little bit about cloud provider experiences. This is basically big companies providing you a bunch of services for developers to use and build your own platforms. Then a little bit about building similar experiences with open source tools and why you need to start thinking about building platforms and platform engineering. We are in the platform engineering track, so we have been hearing a lot about building platforms. And I will not spend that much time on definitions. I will just try to show you kind of like an example that I've been working on. And then at the end, I will just try to describe what I think that it's missing and a lot of opportunities to create new open source projects, initiatives, collaborations, and stuff like that. So as Liz mentioned, my name is Mauricio Salatino. I'm known as Salaboy in the community. That's my Twitter handle. And I work for a company called Diagrid. It's a company that is working on the project that is called Dapper. And I'm also serving as a steering committee member for the Knative project. These are two CNCF projects, and I have the pleasure to work there. Before that, I used to work at Red Hat and VMware, those big software providers that are also building tools for developers. And what I'm trying to really accomplish this year is to finish writing my book that is titled Continuous Delivery for Kubernetes, which is actually about building platforms with the main purpose of delivering software more efficiently. Right? You can take a picture there. There is some discount code there to access the drafts and help me finishing the book. So, cloud providers. I will just go really, really fast because it's the end of the day and I have a lot of things to cover. Cloud providers. I guess that you all know them. AWS, Azure, Google Cloud. Alibaba Cloud is not something here that I hear a lot, but of course that it's pretty big and it has a lot of market share. They are very, very good at providing experiences for developers to use all these services that they provide using a pay-as-you-go model, right? Like you pay for whatever you use. And that's pretty good for small companies that need to start and they don't want to start buying machines. They can just go and use their services, build their applications, and get off the speed, and then figure it out. If they get adopted, they will need to start paying more for those services. It's really interesting to see how they add continuously a lot of services, and they are going up and up the stack. Right? They are just giving you more and more tools just to simplify the things that you're going to build, so you can go really, really fast. All the cloud providers that I mentioned, and others as well, they provide three main things when we talk about experiences. They provide dashboards for managing, monitoring, and and doing all the billing and making sure that you give access to users. But they are all built API first, and that basically means that for all the services that they offer, they have an API that you can access and you can interact with, and that basically means that you can create applications to consume those services in an automated way. And they also provide CLIs. Those are command line interface tools that developers and CI tools like automation tools can use to interact with these services. They all ended up using the APIs at the end of the day, but there are completely different experiences for different personas, different kind of people that it's going to interact with these tools. And I think that that's really important. Cloud providers do this in different ways. Some cloud providers have better experience than others. At the end of the day, it's a differentiator, but it's not the big one, right? Even if the experience is bad, if you have services and it's a little bit more cost efficient, maybe you will go for that cloud provider. This screen here is just a form that allows you to create a Kubernetes clusters in Google Cloud. And it's as easy as that. You just fill a form with some details and then hit the create button, and then you have a cluster, right? Something that doing on premises will require an entire team, a bunch of hardware configured correctly in order to work. With this, you can just go there. It's around 6 minutes to create a cluster. So after 6 minutes, you have a cluster. And the cloud provider here, it's also providing an estimated cost. That's also pretty good, right? So you can basically say, OK, I will create a cluster, and this is what it's going to cost me every month, depending on usage, of course. For all these things, as I mentioned before, you have an API that you can use in order to interact. So if you want to create a cluster, but in a programmatic way, you can send an HTTP request to that URL. As soon as you have an account there, you can just send this request, and then you will create the same cluster that you can create using the dashboard. And you can do the same with the command line tool. In this case, the command line tool is called gcloud, which basically helps you to interact with Google Cloud Services. Same command, you create a cluster. And I think that these three different experiences are really important if you're planning to build a platform. Google Cloud Platform, it's called platform because they are just basically giving you a lot of services and a bunch of experiences around them. But we all know, right? Like if you're saving time, then that means that you're paying money. And if you're saving a lot of time, that basically means that you're going to pay a lot of money for that. And that's kind of like what I've seen happening kind of like in these last 2 years. Like a lot of people running on these very large cloud providers, they are starting to say, okay, this is quite expensive. And if we have like a large organization, they are going to spend a lot of money on those cloud services. So cloud providers, that's kind of like one of the things, where like the more you grow, the more they are going to charge you. So they can start, taking away a chunk of the money that you're making with your company. I've seen a lot of companies in the last 2 years, last 3-4 years, that are starting to think about using more than a single provider, and that might be because they want to use services from different providers, or maybe the company was merging with another company and they both use different providers, so at the end of the day you need to use 2 different providers. And the problem with those scenarios is that you don't want to train people to learn about like using Google Cloud and AWS. That's a very expensive thing to do. You just need to have experts that kind of like know about all the cloud providers. And while you can do that, it's expensive, and these people is very specialized and tend to move around, and it's not easy to keep happy inside your company. So you need to be very careful with that. So the question that I ask during this presentation is, can we use open source tools to abstract away all the cloud provider tools and provide a unified experience for our teams, so they can like stop worrying much about which cloud providers are we using and focusing more on actually building applications and delivering features? And the answer is, of course we can. So we can all go home. But no, let me show you a bit about what I mean by this. So, and that's kind of like where Kubernetes comes into the picture, right? Like, and that's why it's so important. Kubernetes is a CNCF project. I've heard a lot of mentioning in this presentation, so I would assume that everybody knows here kind of like what Kubernetes is. But the important part for this presentation is that we have now an API to be able to deploy and run applications in all major cloud providers in the same way, right? And also, if we want to run workloads on premises, we can use the same APIs. So we have this unification across cloud providers and on-premises workloads. We know that if we use the same API, we will be able to run our applications. And the moment that you start looking into this, in the same way as you look into all the services provided by cloud providers, you will find that there are tons of projects being built on top of Kubernetes to solve different problems. And that's the CNCF landscape, right? Like all these things that you can do with Kubernetes and all these problems that you can solve with it, and in order to just basically deliver applications on top of it more efficiently, with monitoring, with tracing, with GitOps, with all the things that you can think of. Again, if you go to different cloud providers, you can find solutions for the same problems, but those solutions are very cloud provider specific. When you look at this landscape, you will find solutions that will work across cloud providers, which is it's like a pretty interesting proposition. So when you go into that space, open source, Kubernetes, CNCF landscape, and all these cloud native projects, you need to start making decisions, like hard decisions about which projects are you going to use to solve different problems. How do you do GitOps? How do you do your CI builds? How do you monitor your applications? And that's one of the main reasons why you now need to have experts looking into this. The same way that you need like Google Cloud experts to know how to configure Google Cloud for your applications, you will need to have some CNCF, like cloud native experts, to define which projects do you want to use for your cloud native applications running on top of Kubernetes. And that's where you need to start thinking about definitely platforms, building your own platforms on top of Kubernetes, and platform engineering, which basically means having teams dedicated to curate all these projects, decide which ones are they going to use, and more importantly, put an API in front of all these projects so they can provide a contract to our end users. So, without going into definitions, because I think that Avi did a great job yesterday explaining why we need platforms and when and how and for which personas and which teams, I wanted to just show one example on how a platform will look like. And basically, I think that this is not about creating things in cloud providers like databases or message brokers or configurations. It's more about giving developers what they need to do their work. So the scenario that I tend to use to exemplify this is this very simple interaction, right? A development team needs to change an application, right? Like a business application that it's already running in front of our customers. Imagine like Netflix or Uber, like that's already running, right? But we need to make a change. So the teams in there that they want to change maybe some services or adding a new feature, they need an environment to do the work, right? And in order to do the work, they need an environment that it's not only a Kubernetes cluster, right? Like it's just not machinery for running workloads, but it's the application configured, maybe mock data in order to test with the new feature and all that stuff. So they will go against the platform, interact with the platform APIs, and request one of these environments. Whenever they need one, they can go to the platform API and request one, and the platform will provision that environment for them and then give the credentials back to the team so they can connect and start working on that, right? It's really important from the platform perspective to create an environment that it's pretty much all the things that the development team needs in order to start fixing bugs or creating new features. If development teams need to spend time figuring out what's in there, how is it configured, how to access data, how to, all that stuff, they are just wasting their time, right? Like they are just not actually producing new features or bugs. And the moment that you go to the CNCF landscape, you start kind of like figuring out that there are tools to do different things in this landscape, this very like large set of tools. And I think that lately, like last year, I've started classifying these tools into different spaces, right? There are some tools that belong there into the platform. Basically, tools that will just provision things, configure things, or create accounts for users. All these things are in that space, in the platform space. Then whenever we create an environment for a team to start do their work or deploy their applications, we will have environment tools that will make the development team life easier. They will give them all the tools so they can actually code, deploy their workloads, test, and understand what's going on. And finally, something that we haven't been looking that much, there are some initiatives there, but when you look into the Kubernetes space, we care a lot about what happens inside the clusters and how do we run our workloads, but not that much into what's happening in the workstation of the person that is actually creating new features and all the tools that are needed to do that. So I think that that's something that is coming, and I think that there is a lot of people interested in building some solutions there. When you go into Kubernetes, I've seen a lot of companies implementing this, and this is basically how they divide it and the tools that they use to do some of that stuff. I've heard yesterday about like Terraform, of course. Terraform is a great thing. Pulumi is another great tool. But more lately, I've been hearing a lot about Crossplane and how to use Crossplane to basically create these platform clusters. Kratix is another good example of how you can create APIs on there, and Crossplane provides some mechanisms to create these objects that are contracts to our users. The end goal here is, again, if you have a cluster for platform tools, then you will have different clusters for running your workloads, right? Like you're not going to run your applications in the platform cluster, you're going to run that in different environments, maybe the staging environment, the testing environment, or the production environment. And as you can see here, I'm listing some tools there like Crossplane, vCluster, Argo CD for doing GitOps, Tekton for building pipelines like CI pipelines, Kepten for monitoring and troubleshooting of your workloads. Backstage is a very popular project now for building kind of like platform portals. And that makes a lot of sense to be there like in the platform cluster. On the environment side, there are tools like Dapper and Knative that basically helps developer to deploy their workloads and have more flexibility on how they create features and applications. And that's basically providing some abstractions that allow them to consume infrastructure without actually knowing where that infrastructure is, which is pretty interesting. And then on the workstation, on the laptop, kubectl to interact with your clusters, maybe Helm, and maybe some of the tools that are more specific to the work that they are doing. Like, for example, if they are running clusters in Google Cloud, they will need probably the gcloud CLI tool in order to interact with those services. The more that we can abstract from developers, the more that they can focus on writing code instead of worrying about the tools that they need to use. And as you can see here, when I'm creating a new environment, I'm not just creating a cluster and installing some tools. I'm also deploying an application, creating infrastructure like databases, message brokers, creating users in a user database or whatever, right? Again, trying to get everything that the users need to start working on their features instead of worrying about how to connect to a database. So let's do a quick demo. I don't know how much time do I have. OK, I have another 15 minutes, which is kind of OK. Let's see if that works. I will not be showing much, but basically what I wanted to show is a file here. So I have a platform cluster that I configured using bcluster, crossplane, and a bunch of other tools. But what I can do against that platform cluster is to request new environments, like the one that we have been discussing, with some applications installed and some infrastructure being created. So if we see here, I have a file that basically has that environment definition. If you have used Kubernetes before, this is a Kubernetes resource. And that basically means that I've extended Kubernetes to understand what an environment is, right? Like this is, again, this is an environment that is very specific to my domain, right? Like it has an application, it has some infrastructure like databases, and I can, here in the parameters in the parameters section, I can configure some extra details, right? Like I want the environment to be small. I don't want to create a full production with replication environment. I just want it small. And for a developer, they don't even need to care what a small means, right? Like they know that they want to create a feature, so they don't need full production capabilities. They can create a small environment. Here I have a flag saying, okay, yes, I want to create the database that my application will be using, and maybe I want to add some mock data into that database, right? And also create some fake users. So whenever you want to start working, you already have everything you need. As soon as I create this description, if you think about what this is pretty much the same as creating a form in Google Cloud, right? When I was creating a cluster and I had a form, I can give access to development teams to this API, which is pretty low level and it's very Kubernetes oriented, or I can build a higher level abstraction using a dashboard where they can actually have a form to fill all these parameters, right? I've already created one of these environments, but I can create another one here that is called Team C, right? Like I created the Team A environment before, so we can use it, and I will create a new one here by just sending, kubectl apply. I'm sending this resource to Kubernetes, so it actually goes and provisions that environment for me, right? So I just send this command here, that resource that describes what my environment is and all the parameters, and Kubernetes, in this case the platform, replies back, okay, I received that resource, I will provision it for you at some point. Because it's Kubernetes and Kubernetes provides this declarative approach, I can do kubectl get environments and just find all the environments that I have, right? So I have a Team A environment which is running on Google Cloud. I can actually hide this from developers. They don't even need to know where the environment is running. It's not relevant, right? Like this is just an implementation detail. And I have another environment using bcluster, which is a very interesting open source project that you should check out if you are in the cloud native space, to create clusters inside clusters. So instead of going and provisioning a whole new cluster for running your applications, you can use bclusters to save some money there and save some computation power. And finally, I have like the Team C environment that I've just created 23 seconds ago. And it's not ready yet because, again, Google Cloud will take around like 5 minutes to provision it. So I will not wait for that. I will use the one that I've created for Team A already, right? So what I've demonstrated here is the power of using tools like, again, like Crossplane, bcluster. I haven't demonstrated Backstage or Argo CD in this case, but Crossplane in this case, this configuration allowed me to create this interface, this environment resource that defines what an environment is, and I can then declaratively send, that request to the cluster, to the platform cluster, and it will provision things. As I mentioned before, my application will be installed in that environment, and a database will be created, in this case, Redis. So let me show you that here in my, where is it? In my GKE, my Google Cloud Platform account, right? So if I refresh my list of clusters, we should see that there is a Team C here cluster that is being created, right? So it's being provisioned right now. And just to show you that some other infrastructure is being created as well. Not there, so here, memory. Oh, my internet is, there you go. So I'm creating also Redis database for Team C. And that's all being handled behind that interface of the environment interface. When I send that environment resource, all this is being created for me. All this is being configured together as well, right? Like we are linking all these resources. It's not that I'm creating a Kubernetes cluster and a database and then how do I connect these two things together? Crossplane is taking care of gluing things together, sharing the password and the user that I need to use to connect to that database and all that stuff. After the cluster is created, as I mentioned before, the Crossplane composition will also install my application and connect it to the database and expose it to the internet so I can actually access it. Let's go back to the slides. So the infrastructure side of things, I think that we can solve it, like again, using tools like Crossplane, vCluster, maybe Backstage, maybe Cratix, maybe some other tools. There is not a single tool that will solve all your problems, so you need to use a combination of them. And that's pretty much where platform engineering is today on the Kubernetes space. You need to figure out which tools do you want to use to implement this kind of stuff. But there is a big question here of like, okay, we are creating a bunch of cloud resources, but how the developer will interact with all this stuff? Because if you start creating databases and message brokers and a bunch of other things, how do you kind of like give the developer the possibility to connect all these things without them going crazy and figuring out where the database IP is, or even if it's exposed outside of the cluster? And that's where I wanted to show you quickly a couple of things that I've been also working on. And that includes a project that is called Gitpod, but you can also use GitHub code spaces. And these are like virtual development environments that runs on the browser. And you can configure them to have all the tools that you need to do the work that you are supposed to do, right? So in this case, I'm pointing here to a repository that is called State of OpenCon Functions. And I've installed this Gitpod plugin that shows me this button here, right? And this button, what allows me to do is to create a new Gitpod session, which basically will open VS Code in the browser. And I will not need to install anything on my laptop to be able to just go and create some applications to deploy in that cluster, right? The cluster, the environment that I've just created to deploy my applications. And as soon as this session starts, because it actually needs to download and fetch some containers to run this instance of VS Code, I will be able to basically get the credentials, in this case from my new environment, connect, and start coding, right? So I have here a VS Code instance, and the README of the repository basically gives me some steps here to follow. Mostly because I was lazy and I didn't have enough time just to automate all of this. But this is kind of like what the platform team should be doing, right? Like giving developers all the credentials so they can actually do their stuff. If you have worked with Kubernetes, you know that you need to containerize your applications to run them. And that's basically what I need to log in into my Docker account. So I can create containers and push these containers to a registry. And the next thing that I need to do, because I'm using Google Cloud, and this is definitely a place where I do see a lot of improvements and a lot of work that needs to be done to make kind of like a more like multi-cloud experience to log into cloud services. I'm not entirely sure if something exists around this, but what I'm doing now is I'm connecting to Google Cloud Services that basically requires me to log in into the services, into that VS Code instance that is running on the cloud. And for that, I need to access with my account and basically tell Google, yes, this VS Code instance in the cloud is allowed to access your services on my behalf, right, with my account. So that's basically what I'm doing, and I need to select here the Google project, the Google Cloud project that I'm using. And as soon as I'm connected to the Google project that I'm supposed to be connected, I can connect to the environment that I've created before. So I can go here. Again, this is all the things that the platform team should be automating. So developers shouldn't worry about accessing the Google Cloud Console or any of these things to get credentials. But I wanted to show the other side, which is basically having an instance of your workstation already set up for you to be able to do your work. I'm connected now to the Team A environment that I mentioned before, and that environment here, I can make it bigger. It has an application already running. It's a very simple function. It's a very simple function that is deployed using Knative, and I can just list it there. And basically, what I want to do here is I just want to send a curl request, like a post request. And it's a function that basically takes values and store them into the Redis database that I was provisioning, right? So I can do a curl. I need to send a post request. Yeah, so simple stuff. But just to show that we can store some values in there, right? Let's see if it works. It's a function. So yeah, there you go. So here it's basically all the values that I have stored in my Redis database. And again, when I created the environment, I deployed the application, I connected it to the database, and now my application can actually store data into the database, right? That's pretty simple. But now what I wanted to show finally quickly on the last 5 minutes is that I can create a new function completely here in this IDE deploy it into Kubernetes without writing any Docker file or writing any YAML file. Two things that it's actually required to get something running in Kubernetes. But based on the tools that I've installed here, I wanted to show that you actually don't need to do all of that stuff. And I also want to show another thing that I think is important, which is if you want your developers to connect to databases, for example, or send messages using message brokers, you can use a tool like Dapper that allows you to connect to infrastructure without actually knowing where it is and allowing the platform team to wire all the things for you. So one of the tools that I've installed in this instance of VS Code is the command line tool called Dapper that you can use to list all the components here. And as you can see, this list is basically showing that I have a state store in my instance in this case, right? Is the font big enough? I don't know if it's big. I wanted to make it bigger, but it's going to break, right? So I have a state store. And that's all I need to know as a developer. I have a place where I can store data, right? So I can write a function that basically interacts with that state store without actually needing to know where the database is, if it's in Google or if it's in Amazon or whatever it is, or what kind of database it is, which is pretty cool. I don't need to add any dependency to connect to that database directly. I can just send HTTP request or gRPC request to that state store, and Dapper is going to store the data for me in whatever database I selected to configure, right? And again, all that configuration and gluing was done by the platform that created the environment. So next step is I'm going to use another open source tool that is coming from the Knative community that is called Knative Functions. And that's the Func CLI, right? Like this CLI, that it's already installed in the development environment. So in order to use this, I will just create a new directory. I want to create a function called AVG for calculating the average of all the numbers that I have stored in the database. And then I will run a command that I will copy from here because, again, I just don't want to spend time typing. So I will just run this command, func create using the Go language, using a template that understands about Dapper, that I'm using Dapper. And it's stored in that repository, in that GitHub repository, right? I need to go into the directory. Sorry about that. And now I can run the command. So the function got created, and basically this is just a scaffolding, right? I'm just creating a new function using the Go language. I can use any other language that I want to create a function. This is actually polyglot. And then in that function, the thing that I'm doing is I'm using the Dapper Go SDK here to be able to connect to the state store. And the only thing that I need from that state store is the name, which in this case is a state store. It's a little bit confusing, but that's the name that I chose to use. I can change that later on if it makes it clear. And then I've cheated a bit because the template already has the code for calculating the average. But if you see here, the only thing that I'm doing is I'm connecting to Dapper, to the state store, and then just getting the values that are stored there. And that's pretty much it. I have one more thing to do, which is adding another bit that can be automated, that it's a bunch of annotations. So when I deploy this, Dapper that is running on the environment understand that this function needs to be wired up with that state store. So I will just add these annotations. And I think that that's pretty much it. Everything is saved. Everything seems to be nice. And I need to run just the last command here, which is, again, I want to run and deploy this into my environment. And to do that, let's go here. Let's clean up. Let's see if I can clean up. Ooh, it's not cleaning up. That's good. That's a different combination. Yeah, let's do that. Func deploy -v for verbose. And then this is where Docker becomes important. It needs to know where to push, my function. To which registry, right? Remember that I'm working in a VS Code instance in the cloud, that it's connecting to a remote environment that is running on Google Cloud. And that basically means that I need to build a function, like a container for my function, that needs to be deployed to that cluster. And that basically means that the container needs to be publicly available. So after I run this command, the function will be actually deployed into my environment, and it will be running. And it will be also connected to the database that I'm using Dapper, right? Like I'm connecting using Dapper. So it's connecting with that state store, which basically means that when I call the function, I should be able to get the average back from all the values. And in less than 5 minutes, I've created a function connected to a database that I don't know where it is from the developer perspective, but I know that I can use because the Dapper command line tool is showing that the component is there, so I can use it. And I haven't written a Docker file to create my container, and I haven't written any single line of YAML because I don't need to. I'm using the funcCLI command line tool. So let's wait for that. I think that it's pushing the container now to the Docker registry. Yeah, this is pushing to Docker Hub. So as soon as it's finished, it will return back the URL of where the function is, which is publicly available under like a public URL that I can call from my VS Code in this case, or from my laptop. It doesn't really matter from where I call it. So that's pretty much it. The function, I think, is starting. If everything goes well, this is a live demo. This is actually running in a cluster now. And there you go. I have the URL here. So we can do curl. And somewhere the average should pop up. There you go. Like the average is 64. Hey, there you go. What a way to finish my presentation. I have one more slide, which is about what's missing, which I think is important. It's an important part of the presentation. Again, I just showed Gitpod, Dapper, Knative, and build packs to create the container. That's why you don't need to write any Docker file for that. And just to go back to what I was trying to show at the beginning, right? Like we have a platform. We requested a new environment. We enable our teams to use a self-service approach so they can define and send basically a request whenever they need an environment. There is no need to interact or create the Jira ticket for that environment to be created. Everything is fully automated, so you are optimizing on there. We are trying to reduce the cognitive load, right? Like they don't need to actually know where these things are created. They don't need to know where the environment is. As soon as they know that they're having an environment with the parameters that they have set up, everything is good. They should be able to go and do the work. This is a truly polyglot approach because we are using, in this case, Dapper, that you can use any language to connect to the different infrastructure components and have the right abstractions in there. And we have glued several open source projects together in different places, right? Like in the CLI space, in the platform cluster, and also in the environment cluster to provide like an unified developer experience. Something that for me it's very important here to mention, again, you need to create, at some point in the platform engineering space, you will need to provision a lot of infrastructure in the cloud, in multiple cloud providers. Crossplane is giving you some of that. On the other hand, you need to enable your developers to consume all this infrastructure that gets created without pushing them to know where that it is, where the services are running. And Dapper is kind of like good at that as well. What's missing? When you go to the CNCF landscape, the CNCF, it's a perfect foundation to see how innovation happens. But there are a lot of things going on. So it's very difficult to catch up. And it's also very hard when you try to make two projects work together that weren't designed together or were not designed for certain use cases. So you need to spend time there, go back to the projects, collaborate, improve, share your feedback, share your use cases so the projects can start adopting all these things. CLIs, like as you've seen in the Gitpod side, I've used different CLIs to do different things. If you are building a platform teams are usually building their own CLIs. And I do feel that there is a place there to create projects that simplify all that experience. Projects like Backstage will give you that kind of like dashboard feeling to your platforms. And there is a lot of things going on in that space. So I encourage you to get involved in there. But again, if you're building a platform on top of Backstage, there is a lot of work that you will need to do there. And then managing credentials, as you saw, like it's not that clear which projects I should use to have like a, like a multi-cloud credential management for my team. So I don't need to actually spend time connecting to services that they shouldn't be even like aware that they are there, right? Like they just should be able to do their work, click a button, connect, and then just interact with the services that they are supposed to interact with. That's pretty much it. I think that I'm way out of time. Sorry about that. But if you have any questions, feel free to grab me outside.
We're only a couple of minutes over time, so if there is a question or two, we can take that. Anyone got a question? Was that just a wave?
That's good.
If this was an auction, you'd have done a bid there. Was that a wave?
There's one there. Sorry, I know it was a little bit rushed, but it's like long presentation made short.
So what do you think the ultimate endpoint is for this? Will it be like we've all got Chromebooks and everything all runs in the cloud?
Can you repeat a little bit louder?
What's the ultimate end point you're going to get to?
Yeah, so the idea here, I think that like having a clear interface to create environments for teams to work, I think that that's the first thing, right? Like having an API to say, okay, I want an environment for my development team, or I want an environment for my data scientists. Those environments will have different tools, but at the end of the day, the kind of like the interface should be pretty similar. And you should be click a button and get an environment, get working, right? And then the other thing that I'm not showing here is how do you take the things that are happening in that environment into actually in front of your users to the production environment. So the platform should have all the tools to make sure that they can take all the work that is happening in these environments and just move it down to different environments until it reaches kind of like the end user. And on the other side, on the tooling side, I think that the end goal is to have some sort of like unified multi-cloud experience for developers to say, I want to use these services. I don't even know in which cloud providers are those, or even if they are on premises, but I can connect and use them without like thinking too much about credentials and all that stuff. Yeah. Great.
All right. Thank you so much. Let's give a round of applause.